I'm Anil Kumar. Welcome to my series on vectors. We'll talk about some applications to geometry in this particular video. So first of all, I'll derive a very important formula which we call section formula. At times you also see it as division of a line segment, and based on that we'll have few questions. Here what you are seeing is all the questions which we are going to cover in this particular video, and that will complete almost all what you need to know of vectors application to geometry. So the very first question here is to express OP as a linear combination of OA and OB when P divides AB in the ratio of m:n. It really means that if I have a vector AB, for example, in that case, if we have a point P here, which divides AB in the ratio of m:n, then how is OP related with OA and OB? And that is also called the section formula. The formula basically is something like this. OP is equal to n over m plus n times OA, these are all vectors, plus m over m plus n times OB. Now this is extremely important formula which will be utilized in many of these questions to solve. That's why I've mentioned it here. Now the second question is, show that the midpoint of adjacent sides of any quadrilateral are joined, then the resulting figure is a parallelogram. Question number 3. Prove that the diagonals of a rhombus intersect at right angles. So we'll use dot product to prove this. 4. Prove that the three medians of a triangle meet in a point which is called centroid that divides each median in the ratio of 2:1. 4. This is a very important test question, a bit complicated. In parallelogram ABCD, E is the point on BC that divides it in the ratio BE to EC as 2:1. The diagonal BD intersects AE at K. Calculate the ratio in which K divides AE. The last question here is based on the very first one, which says express OP as a linear combination of OA and OB when P divides AB in the ratio of 4:1. It's a multiple choice question where you can apply the formula and select the right answer. So these set of videos will now be discussed at length. We'll have a small break in between, and then I hope by the end of the video you will understand most of the concepts required for this topic. So let's go through the very first question and understand how to derive this very important formula. I'm Anil Kumar. Welcome to my series on vectors. We'll take a few applications to geometry in this particular video. Let's begin with a very important concept which is also referred to as division of a line segment. So let me write down here division of a line segment. The equation could be something like this. Express OP as a linear combination of OA and OB when P divides AB in the ratio of m:n. Right. Now we'll derive a very standard formula which will be utilized in solving many questions. So let us say we have a vector AB, right? So this is the vector AB for us. Let us take any external point O, right? So you could think as if it is from origin. So you get a position vector OA from here, right? And OB. So these become your position vectors. If O is considered as a point on the origin. Now what we are saying here is that express OP, so some point P is here, which divides AB in the ratio of m is to n. So let's take a point here. Let's say this is our point P, which divides AB in the ratio of m is to n. That means this is m and that is n. So we need to express OP in terms of OA and OB. That's the question. Perfect. You can always pause the video, answer this question, and then look into my suggestions. Now, one of the easiest way to solve this or prove this or find the formula for this is to use scalar multiples. So let's look into what AP is and what is PB. So AP and PB are in the same line as AB. They are collinear, right? So we could write AP as equal to m times AB. We could write PB as n times AB, right? So these are vectors. Now if I multiply this by n and that by m, what do we get? So if I write n times AP, I'm multiplying this by n, then I get n m AB, right? Here if I multiply this by m, I get m times PB will be equal to n m AB. You see both become equal, correct? So when you do that, multiplying the first equation by n and the other by m, in that case we find that the right side is equal, or we could now write that n times AP is equal to m times PB. Correct? Now what is AP? A to P could be written as OP minus OA, right? So A to P is OP minus OA, and P to B is OB minus OP. Perfect. Now we can bring OP to the left side to find an expression of OP in terms of OA and OB. As you can see, in this particular equation, we only have OP in terms of OA and OB, right? So bringing it to the left side, we get n plus m, or let's do it in two steps. Let's open this. N times OP minus n times OA equals to m times OB minus m times OP. Right. So bringing it here, we could write this as m times OP plus n times OP is equal to m times OA, bringing this to the right, plus m times OB, right? So m and n are common, OP is common, so we could write m plus n, scalar multiples, using the property of, associative property of addition. We get here m times OA plus, what did I do? N, this is OA is with n times, so this is n, right? So n OA I took to the right, so this is n. And we have m times OB. So basically OA gets multiplied by that number, right? And OB gets multiplied with this number. So we get an expression for OP as n over m plus n OA plus m over m plus n OB. Correct. So this is a very important formula. Let me rewrite this formula here. It is also called section formula, right? So sometimes it is referred to as section formula. So OP is equal to n over m plus n, the whole length of AB, times OA plus M over M plus N times OB, right? So this is the formula which will be utilized many times when we are talking about geometrical applications. So I hope that makes sense. So go through this and understand how we derived it. Many questions could be solved using this method itself, which we have utilized, correct? I hope that makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that will be great. Thanks for watching and all the best. I am Anil Kumar. Welcome to my series on vectors. Here is a multiple choice question based on division of line segment. The question here is, express OP as a linear combination of OA and OB when P divides AB in the ratio of 4:1. So let me sketch the segment, which is for you from A to B. And we have an external point O. You can treat this as the origin, right? So this is your external point O. Now it makes sense. Express OP. So P is some point in between. Okay, let's do it like this. So that is P for you. So express OP as a linear combination of OA and OB when P divides AB in the ratio of 4:1. So this is 4 and this is 1. Okay? That's the question for you. So if you know the formula for division of line segment, it is straightforward. Let me give you the formula for line segment. I'll also provide you with the link for the proof of the same. So the line segment formula is that OP should be equal to this ratio. If this is M is to N, in that case, N over M plus N times OA plus M over M plus N times, OA, this is OB. So that is the segment formula which you can utilize and then get the answer. That is one way of doing it. Now let us say that you do not remember this formula. Then how are you going to do it? So that's the whole idea. So let's look into this. So AP is 4 and PB is 1. That is the ratio. So we could write this as AP is equal to 4 times PB, right? Since P is dividing this in the ratio of 4:1. Now what is AP? AP is OP minus OA. So we could write this as OP minus OA is equal to 4 times P to B is OB minus OP. Now we need to isolate OP. Let's bring it here. So we have OP, bringing this here, minus becomes plus 4 OP. And taking OA on this side, we get OA plus 4 OB. Correct? So that is 5A OP is equal to OA plus 4 OB. So OP is equal to 1 over 5 OA plus 4 over 5 OB, right? So that is our option number 1. So we get A as our answer. Do you get the idea? So simple to prove. However, if you know the formula, it makes it much simpler. So this is a very useful formula to remember. I would like you to make a note of this, as this is also a very popular question in most of the test papers relating to vectors, right? I hope it helps. Feel free to write your suggestions, share my videos, and if you like and subscribe to them, that'd be great. Thanks for watching and all the best. I'm Anil Kumar. Welcome to my series on vectors. We'll take a few applications to geometry in this particular series. The question here is, show that if the midpoints of adjacent sides of any quadrilateral are joined, then the resulting figure is a parallelogram. So let us construct a quadrilateral. So we'll just construct a general quadrilateral, not a rectangle or a square, right? So let's just make a random one, right? So it doesn't look like any regular one. Now what we are going to do here is join the midpoints. So let's say these are the midpoints for our quadrilateral, right? So we'll just join them. We need to prove that they form a parallelogram. That is what we need to prove, right? So I hope the concept is clear. So this is the quadrilateral A, B, C, D given to us. And the midpoints means these are the points which we are talking about. Let's say P, Q, R, and S, right? So these are the midpoints. Okay. Okay, these are the midpoints. Now, we need to prove that PQRS is a parallelogram. Okay, so the easy way to prove is that we can begin from any one side. So let's talk about QR. So what is QR equals to? So QR is equal to QB plus BR, right? QB plus BR. So that is QR. Now QB could be written as half of AB. So QB is half of AB since we know Q is the midpoint, and BR is half of BC, right? It is half of BC. Correct? Now, so it is half of, we could also write this as AB plus BC. Now AB plus BC is what? Well, let's join it. AB plus BC, we can join this. That is what it is, right? So it is half of A to C, right? So this is equal to half of AC. So we know what QR is. Now let us figure out what is PS. Is it same as half of AC? That's what we need to prove, right? So let's begin with PS now. So P to S is P to D plus DS, right? Now P to D is half of AD since P is the midpoint, right? Okay, and DS is half of DC. So we could again take half common, so we get AD plus DC. And AD plus DC is AC, right? So we get this as half of AC. So comparing equation 1, this is R1, which is we are writing QR is equal to half of AC. And now we got this PS, the opposite end, is half of AC. So both are same, right? So that shows that these are equal and they are parallel, correct? So they are opposite sides are parallel, correct? Now you could use the same strategy. So I like you to use the same strategy and then figure out what PQ is. So you can say the same thing. So PQ will be equal to P to A plus A to B half, right? I should write P to A first, right? Okay, so P to A plus A to Q, which is half of AB, half of DA, P to A, right? Half of DA plus half of AB, which is half of DA plus AB, which is half of, so this is half of the other diagonal, which is D to B. Correct? So we got PQ. Now let's see what SR is. So same strategy. S to R will be SC plus CR, which is half of DC plus half of CB. That means it is half of DC and CD is half of BD, right? So you can write this as half of, I should write DB, right? half of dB. So again, we have shown that they are also equal, right? So we got this PQ equals to SR, correct? So they are parallel and they are equal. So that is how we can say that PQ RS is a parallelogram. Perfect. So that is how you would actually prove it. I hope it is straightforward and simple. So from here, we'll take a few complicated applications of geometry. I hope that will help. Feel free to write your comments and share your views. If you have some questions, feel free to post them. Thank you and all the best. I am Anil Kumar, sharing with you a few applications of vectors to geometry. Here is a very interesting question. You need to prove that the diagonals of a rhombus intersect at right angles. Right? So let's make a rhombus. Rhombus is a quadrilateral where opposite sides are parallel and equal. Right? So that is a rhombus. So what we are given here is that these sides are parallel, the opposite sides, it's a parallelogram, and all are equal, right? So all sides are equal. Correct? So that is a rhombus. Now, we need to prove that the diagonals intersect at right angles. So let's label this. Let's say this is ABCD. And the diagonals are AC and B to D. These are your diagonals. So we want to prove that they intersect at right angles. Correct? Now, in this particular case, we know that the magnitude of AB is equal to the magnitude of BC, which is equal to the magnitude of CD, is equal to the magnitude of AD or DA, right? So that is given to us, and we are also given that they are equal vectors. So AB, vector AB is actually equal to vector DC, and the vector AD is equal to vector BC, since it is a rhombus. Correct? Now, to prove that they are intersecting at right angles, we will find the dot product, right? So basically the concept is that the dot product of these two diagonals, which is AB and BD, AC and AC and BD, should be equal to 0, right? So that is what we want to prove, basically. If that happens, then they are intersecting at right angles, correct? So let's begin by finding what the dot product is. So let's see what is dot product of AC with B to D. Now AC could be written as a combination of AB and BC. So we could write this as AB plus BC dot B to D is CB, BC plus CD. Correct? Now AB and CD are opposite vectors. So I could also write this as AB plus BC dot BC minus, instead of CD, we could write AB, right? Now let's expand. So we have AB dot BC, and then we have minus sign AB dot AB. With BC, we have BC dot plus sign BC dot BC minus sign BC dot AB. Correct? Now AB dot BC and BC dot AB is one and the same thing, so they cancel out. All right, they cancel out. So you are left with these two, which I'm going to rewrite. BC dot BC, this is, so BC dot BC is basically the square of the magnitude. Let me write here first BC dot BC minus AB dot AB, right? So that is the magnitude of BC square minus the magnitude of AB square. And these two magnitudes are equal, right? So magnitudes of AB and BC are equal. We are given that since it is a rhombus. And therefore, this is equal to 0. Perfect. Since the dot product is 0, they are going to intersect at right angles. Okay? So therefore, the diagonals intersect at right angles. I hope that is clear, right? Feel free to share your comments and views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best. I'm Anil Kumar sharing with you a test question on vectors applications to geometry. The question here is, in parallelogram ABCD, E is a point on BC that divides it in the ratio of BE is to EC is 2 is to 1. So BE is to EC is 2 is to 1. The diagonal BD intersects AE at K. Calculate the ratio in which K divides AE, right? That is the question. Now, you can always pause the video, answer the question. Here is my thought on this. Let us assume that K divides AE in the ratio of, let us say this is P, and the other portion will be 1 minus P. We are using 1 unit. So in the division formula, division of a segment formula, this sum will be 1. So that is the advantage of using P and 1 minus P. So we will kind of avoid fractions. That's the whole idea, right? So what I'm trying to say here is that AK is to KE is in the ratio of 1 minus P is to P. That is what I'm trying to say. Is that clear to you? Right? Now, if that is the case, in that case, how can I describe BK as? Now, BK will be P times BA, right? So, B to K will be equal to P times B to A plus 1 minus P times B to E. So at this stage, I have utilized the formula which we derived on division of line segment, right? This is the formula which we have applied right there. Now this formula actually finds huge application. Whenever you have division of line segment, you have to refer to that formula. I'll provide you with a link on the same. Correct? So we get our equation. So we have utilized our formula for division of a line segment. Whenever it is divided into a fixed ratio, that is the formula which we can use. P plus 1 minus P is 1, and therefore the denominator P over 1 is not mentioned here, right? So that is how we can write BK as. Now here we know that BE is to EC is 2 is to 1. So we can consider this to be 2 over 3, right? So we can write BE as equal to 2/3 of BC, right? That is given to you. Now, BC is equal to AD, so I could also write this as 2/3 of AD. So BE I have mentioned as 2/3 of AD. So replacing in my first equation, so let's number these equations. Let's say this is equation 1, this is 2, and this is 3 for us. Now, we'll replace BE here with 2 over 3 AD. So we can write BK as equal to P times BA plus 1 minus P times 2/3 of AD. Let's call this as our equation number 4. So we have one relation of BK. Now we'll try to find another relation of BK using the diagonal B to D. Let me divide this in the ratio of S. Let me use another ink. S, and we'll use this as 1 minus S. You understand why? Ratio, the whole side is taken as one unit, right? Okay. So this is S of BD, right? So we can write BK as equal to S times BD, right? Scalar multiple, B to D. But what is B to D? B to D could be written as BA plus AD, right? So I could write this as S times BA plus AD. So we have BK now, two equations. So both should be same, right? Both should be same. Now we can equate 4 and 5. Both are describing BK. So if you equate them, you get P times BA plus 1 minus P times 2 over 3 of AD is equal to S times BA plus AD. We can bring the terms together. Bringing S on this side, we get P minus S times BA. And AD is common here, so we can say plus 2 over 3 of 1 minus P minus S of AD is equal to 0. Now, since BA and AD are non-collinear, is not in same direction as AD, this linear combination could only be 0 when individually these two are 0, right? Coefficients should be 0. That is what we're trying to say, right? So what we are trying to say here is that since, as you can see, that these two lines, vectors, are not parallel. So we cannot have some of these as 0. Now that is 0 only when PS or P minus S equals to 0, or this whole thing, which is 2 over 3, 1 minus P minus S equals to 0, right? So these are the two conditions. Now from the first condition, which is P minus S equal to 0, we get P equals to C, right? So P minus S equals to 0 implies P equals to S. So we can put this into the next factor, which is 2 over 3. So we want 2 over 3 times 1 minus P minus S, instead of S I'm writing P, should be equal to 0, right? So substituting S in the next equation, we call this as our equation number 6, right? Let's call 7. So 7 in 6. We can now find what P is, right? So multiplying by 3, we get 2 times 1 minus P minus 3P equals to 0. 2 minus 2P minus 3P equals to 0, or 2 minus 5P equals to 0. That gives us 5P equals to 2, or P equals to 2 over 5, correct? So this P is 2 over 5. So that means 1 minus P is how much? So 1 minus P will be 1 minus 2 over 5, which is 3 over 5. Okay? So we get our ratio now. So that means that the ratio 1 minus p is to p is 3 over 5 is to 2 over 5, or 3 is to 2. So the ratio in which it divides is 3 is to 2. Perfect. So now we know that AK is to KE is equal to 3 is to 2. So that is how we can actually prove it. I hope you find it interesting and useful. Now this is a very important question from test point of view. I'd like you to go through it once again, try to understand what we have done here. And then if you have suggestions, feel free to make your suggestions. If you have questions, ask them. I hope you find it interesting and useful. Thanks for watching and all the best. I'm Anil Kumar. Welcome to my series on vectors. We are discussing some applications to geometry. Here is a question for you. Prove that the three medians of a triangle meet in a point that divides each median in the ratio of 2:1. So in this particular proof, I'm going to use a formula which we derived and which is called a section formula or division of line segment formula, right? So here is the formula which we are going to use now. So if I have a line segment which is divided by a point P in the ratio of m is to n, then O to P is given as n over m plus n times OA plus m over m plus n times OB. So this is a very standard formula which is always utilized whenever we talk about division of a line segment. So I'd like you to make a note of this formula, and we are going to utilize it in the proof for the given question. Perfect. I'll also provide you with a link so that you can always look into the proof of this particular formula, right? Okay, now let's try to answer the question. We are given a triangle and then we want to prove that the medians of this triangle will be divided in the ratio of 2:1. So let's sketch one triangle here and let's call it triangle ABC. Okay, so we have a triangle ABC and let us say that A is connected to the midpoint of BC. So let's say this is a midpoint of BC and we join A to midpoint, and this point is D for us. Correct? Since D is a midpoint, we know BD is equals to DC. Now what we have done here is we have taken D is midpoint of BC, correct? Now join A to D and take a point on AD which we'll call as G. G is for gravity. This point is also called centroid, and therefore normally for centroid we write G, right? So center of gravity actually acts at this point, right? Now we'll take a point G so that AG and GD are in the ratio of 2:1. You get an idea. So let G be on AD such that A to G is to G to D is equal to 2:1, right? I'm not saying this is the point where the medians intersect or this is the centroid, but I'm just taking a point G, right? And I'm joining A to the midpoint. Now on that median, of course AD is a median, we have a point G which divides AD in the ratio of 2:1. Okay? What we need to prove here is that for all such medians that G point is common. This is what we need to prove. So to prove it, what we will do here is, as we did in the derivation of our formula for the line segment, we'll consider an external point O and kind of repeat this formula and find what is O to G, right? That is the strategy. So now we'll consider a point O, which is, let's say, outside this triangle. Okay, so let's consider a point O here, external point. You can say origin. And from O, we want to find what OG is, a position vector, correct? So OG could be written in terms of OA and OD using the section formula, right? Or the division of line segment formula, which I just said. So we can now write OG is equal to, since the division is 2:1, 1 over OA, 1 over 1 plus 2 times OA plus 2 over 1 plus 2 times OD. Correct? So that becomes OG using the formula which I shared with you. Correct? Okay. Now you can rewrite this as 1 over 3 of OA plus 2 over 3 of OD. What is OD equals to? OD is the midpoint of OB and OC. So we know that OD is basically equal to OB plus OC divided by 2. So if I replace this here, we get O to G as equal to 1/3 of OA plus 2/3 of OB plus OC divided by 2. Right? Now, if you open this bracket, this 2 and 2 cancel, correct? So you get OG is equal to 1/3 of OA plus OB plus OC. Do you see that? So this point G could be represented as OA plus OB plus OC, right? Now, as you know, this is the median, right? So O to G is the average of all the three, correct? So that is the median. So what we did here was we took one median and then proved that OG is equal to all this. Is that okay? Now, what you could do is you could take another median which is on AC from B, right? You can take another median. So let's say this is E. In that case, let's say the point is G dash now for you. So you'll find that OG dash is also equal to OA plus OB plus OC divided by 3. Since these are independent, you see that? So that could be shown for each median, right? So for each median we could say. So if I take the midpoint on AB and let's say this point is F, and let's consider OG dash, some other G, right? So if we have another OG dash, right, some other point on this median, following the same method, we will again show that that is also equal to OA plus OB plus OC divided by 3. So all the 3 points is same. That means G, G dash and G double dash are exactly same, right? So therefore, we can see that the centroid is a point where the medians intersect. Centroid divides each median in the ratio of 2:1, correct? So individually we could show for each median following the same method, right? So that is how we could prove it. So I hope you find it interesting and useful. Feel free to write your comments and share reviews. We'll take few more applications where this formula, which is known as the section formula or division of a line segment formula, will be utilized. I hope that makes sense. Feel free to make your suggestions, share my videos with your friends, and if you like and subscribe to them, that will be great. Thanks for watching and all the best.